Hey, 20-1s. Welcome to the last lesson in this unit. What we're going to do in this unit is this lesson, we're going to look at something called a reciprocal function. All a reciprocal is this. Say I gave you 4. Well, the reciprocal of 4 is 1 over 4. Or if I gave you 2/3, the reciprocal of 2/3 is 3/2. Well, we're going to do the same thing here. But instead of looking at just constants like that, I'm going to say, if I give you x, we're going to look at the reciprocal of that 1 over x, and we're going to look at that graph. Okay, so that's where we're going to begin. Now, in 20-1, we don't spend a ton of time on this, just this one lesson, but next year in 30-1, you're going to spend a lot more time on these reciprocal functions. So this is going to form a really good base for next year. All right, let's look at y is equal to x first. Okay, now I know what y equals x looks like. It's a straight line. However, my friends, what I want to do, and follow along with me, is I'm just going to make a table of values here. Okay, so I'm going to make input, output, x and y. And I'm going to start at, I don't know. I'm going to go start at -4, and I'm going to go like this. And I'm even going to get in a half here, okay? And maybe I'll even get in -1/3, and then 0, and then I'm just going to pop down to like there. Okay, well, the output's really easy because it's y is equal to x. So the input and the output are actually the same thing, right? Because it's y is equal to x. It's a straight line. Okay, so I mean, it's really easy. Just graph that. So we know this is a straight line. So it's going to form a straight line. And wish I had a ruler feature on this, but there we go. It's pretty straight for a guy who's got a lot of coffee in him. Not bad. Okay, what I want you to do here is I want you to pause the video and I want you to complete the table of values for the reciprocal of this using the exact same values. So I'm going to input the exact same values. So -4, -3, -2, -1, -1/2, -1/3, 0, 1, 2, 3, 4. All right, so I want you to pause the video. I want you to find those y values, and I want to see if you can actually graph it yourself. I'll see you in a moment. Okay, let's see how you did. So if my input was -4, my output would be -1 over 4, and -1/3, -1/2, -1, -2, -3, 1 over 0, question mark, 1, 1/2, 1/3, 1/4. Okay, let's draw the table of values here for the reciprocal. So here we go, starting from left to right. So -4 is at like 1/4. It's kind of hard to draw, but it's about there. And then -1/3, it's about there. And then -1/2, it's about there. And then -1, -1. It's right on that original graph. Like it's right over here. Interesting. Interesting. -1/2, -2. -1/3, -3. And do you see what's happening here? We're getting really, really, really close to the y-axis. Oh, but we don't touch it. Why not? What happens right here? 1 divided by 0. Well, we can't divide by 0. The world explodes, right? You can't have one cookie and say I'm breaking it up into 0 groups. You can't. You have to have a group. Okay, we'll see what happens in a moment. Okay, we flip to the other side. 1, 1. Oh, look at that. It's right on that original graph. 2/2. So it's about there. 3/3, 4/4. And if I had included it, I should have included it. I just kind of ran out of room. If I was at 1/2, I'd be at 2. And if I was at 1/3, I'd be at 3. So here's what's happening, friends. When we go to draw this, as our numbers get really, really, really small in the negative direction, what's going to end up happening is this graph, it's going to be getting really, really, really close to 0, but it's never going to touch it. So as x goes to -infinity, the y values go to 0. And as x gets close to 0, it's going to get really, 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 really small in the negative direction. It's going to go like that. And this is a symmetrical graph, so it's going to look like this. So it's a bit difficult to draw, but that's what that looks like. There's some really important things going on in this crazy graph. Okay, here are these crazy things. We never in 20-1 touch the x-axis. What that's called is called a horizontal, right? Makes sense. It's a horizontal line, a horizontal asymptote. We never touch it. There's no input, no x value that I can sub in here that will ever give me 0. We've also got this imaginary line right here, which I'm trying to draw on top of the y-axis, that we never touch either. This is known as the vertical asymptote. So again, the reason why there's this line here is we can't divide by 0. What we're actually talking about is the beginning of calculus, okay, which are known as limits. What happens as x goes to positive and negative infinity? And what happens as x gets close to 0 from the left and from the right? That's the beginning of calculus. It's called limits. But for now, that's what I need you to know. That's what that basic graph looks like. What does it look like in our graphing calculator? Well, I'll show you. Grab your graphing calculator too, of course. I want you to graph 1 over x. So I've got it in. And when I go and hit graph, my calculator doesn't do a good job. And mine's a nice looking color one. Like it looks like the graph stops going up as it gets close to 0 and stops going down as it goes close to 0. It doesn't, okay? And it also makes it look like my graph is touching the x-axis. It doesn't, and it won't in 20-1. In 30-1, it will certainly have different features to this graph, but for now, it won't. So I need you to know what this graph looks like. There it is. And I need you to know this really important information. Okay, what's our domain? Well, our domain is infinite, but it can't be 0. So I could write it like that. Or if you wanted to use interval notation, you would say union. That's what that symbol is right there. That. Okay, the range. The range is the same thing. We had that horizontal asymptote. It's called that line that we approach that we never touch. So y can be anything. There can be any output except for 0. And guess what? Our range is written the same way in interval notation. Okay, our horizontal asymptote, this line that we approach, that's the line y is equal to 0, right? It's the x-axis. Again, when we get to calculus, we're going to describe that by saying the limit as x goes to positive and negative infinity. Okay, so there's your first little mini lesson in calculus. The vertical asymptote. The vertical asymptote is x is equal to 0. That's also known as the y-axis, just like that. Okay, so invariant points. Well, what does that mean? Well, vary means I'm changing. So invariant means I'm not changing. So what point didn't change from the original graph to the new graph? Do you see? -1 is on both graphs, and 1 is on both graphs. So these points don't change when we took the new function or when we transformed into our new function. So the points that don't change are when y is equal to 1 or when y is equal to -1. So our original invariant points are 1, 1, and 1, -1, -1. Those are your original invariant points, okay? Now, this is super important for next year. Again, we're gonna spend, it's not super important, I don't know, but you're gonna spend a few lessons on it in 30-1 for sure. So we want to know the basics of what this graph looks like and where it came from. And if, like I said, if you're going to go into calculus, you're going to start talking about limits. Okay, just a little preview for you. All right, let's try something a little more complicated now that we know our base function. So what do? First thing we'll do, we're going to sketch x plus 2. So what do I know? My y-intercept's at 2, my slope is 1. So there's x plus 2, just like that. And so I draw it in. I'll try to draw it straight again. Too much caffeine in me right now, but almost hit most of the points. Okay, there's x plus 2, right? There's f of x. So what we're going to do now is we're going to graph 1 over x plus 2. We're going to graph this one. And we can call it g at x, like that. Okay, here's what happens. Where I'm going to look first thing I'm going to do is I'm going to find my vertical asymptote. Well, my vertical asymptote comes from when we try to divide by 0. Well, what makes the denominator equal to 0? Well, x can't equal -2. Would be called our non-permissible value from the last unit. So in this unit, what we're going to say is we want to make the equation of the line. Our vertical asymptote's at -2. So I'm going to draw that in right there. Okay, our horizontal asymptote. Well, our horizontal asymptote in 20-1 will always be the x-axis. Okay, in 30-1, that's certainly going to change. But in 20-1, they take it easy on us. It's always at 0. So I'm going to draw that in. Bang, 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 bang. Okay, next thing I want to find is I want to find my invariant points. Well, my invariant points are when y is equal to 1 or when y is equal to -1. So I can just go to my graph and find those points. There's 1 right there, and there's 1 right there. Okay, just like that. If I wanted to find that algebraically, what I do is I sub it in to my equation like this. And then I'm going to solve for x. There's x, there's 1, boom, boom. And here's the other one. So minus x minus 2 is equal to 1. And so now I'm going to get -3 is equal to x. So my point would be -3, -1. And do you notice when I go back up to my graph, that's exactly where those 2 points were. Okay, and now friends, I mean, that's enough. I can see what's going to happen here because I know I'm going to, in this top portion here, this arm is going to approach that vertical asymptote, go through my invariant point, and there you go. And on the other side, it's going to look like that. Okay, so again, what did we do? Found the vertical asymptote. Again, there's 2 ways to do that. I can look at what is my non-permissible value, or I can look at the original x-intercept of the linear graph. Horizontal asymptote's always going to be at 0 and 30-1. My invariant points are when y is equal to 1 or -1. So I can algebraically find those by subbing that into the graph. There it is. Okay, if I wanted to write the domain and range of this graph, okay, so domain. It's infinite except for we can't be -2. Just like that. Range is going to be this. -infinity to 0, union 0 to infinity. There you are. There's your invariant points. I mean, there's everything you need to do to draw one of these graphs. Now, what you will look at is one more. Let's sketch the graph of a reciprocal. Okay, this one's going to be a little bit trickier. So to get the graph of the reciprocal, of course, what I'm going to do is I'm going to find my intercepts first. So I'm going to say my x-intercept, I'm going to let y is equal to 0, right? So we've done this before, haven't we? and I'm just going to factor it at the exact same time. So I know my x-intercepts will be at negative 3, 0, and 2, 0. So negative 3, 0, 2, 0, like that. Okay, I also know my y-intercept right off the bat, don't I? My y-intercept's at negative 6. Okay, there we go. Okay, so if I want to find the vertex of this thing, again, what we can do is complete the square. So if I want the vertex, I'm going to complete the square. So I'm going to go f at x is equal to, right, x squared plus x minus 6, right? Middle term divided by 2 is 1/2. Squared is a quarter. Balance it by subtracting a quarter. So I'm going to get x plus 1/2 squared. And when we subtract these two guys back here, we get negative 25 over 4. So where's our vertex at? Vertex is at negative 1/2, negative 25 over 4. Okay, so negative 1/2 and 25 over 4 is almost just a little bit bigger than negative 6, right? So, I mean, it's just right about there. Okay, good enough. Okay, and looks like that. So what will the graph of this look like then? Well, the graph when we have a quadratic is going to do this. Let's find our vertical asymptotes. Well, our vertical asymptotes come from the x-intercepts of the original, like that. Just like that. There's your vertical asymptotes. Okay. Horizontal asymptote in 20-1, it's always at 0. Now, how do I find then where do I draw this graph? Well, let's find our invariant points. So again, to find our invariant points, I'm just going to do this one graphically, okay? But to find my invariant points, that's when y is equal to 1 or when y is equal to negative 1. So I'm just going to do this one visually, okay? I'm not going to actually find them algebraically. But more or less, that's when y is 1. So there's 1 there. There's 1 there. When y is negative 1, there's 1 there. There's 1 there. And now I'm also going to figure out where this vertex moves. Well, that vertex was at roughly just a little bit bigger than negative 6. So when I take the reciprocal of it, it's going to be really, really small. It's going to be about there. Okay, friends. Oh, we could even move the y-intercept too. It's going to be like, I don't know, about there. Here we go. Here's what the graph of this thing looks like. It's going to come along here, and it's going to go right up like that. Over here, it's going to come down. It's going to, oops, I missed my invariant point there, but it's going to do that. Okay, and this middle portion here, it's going to do this. It's going to make almost a U shape like that, just like that. Okay, so there's what the graph of the reciprocal of a quadratic is going to look like. Okay, so again, you've got some key things, but where you always want to find first, you want to find your x-intercepts because your x-intercepts give you your vertical asymptotes. Your horizontal asymptote is always at 0 in 20-1. It'll be very different in 30-1. Find your invariant points and you're good to go. Okay, friends, that's it. Last lesson in the unit.